Okay, so here we are. We are now on to Unit 4 review. So the first question wants us to solve this radical equation algebraically. Okay, so we can't do it graphically. It has to be algebraically. Now, whenever you have a radical equation, the first thing we want to do is we want to try to get the radical all by itself on one side of the equation. So see this plus 5? We're going to start off by subtracting it from both sides of the equation. Okay, we're trying to isolate the radical. That's step 1, isolate the radical. All right, so now we're left with radical 49 minus 10x. Let me just extend that a little more. Equals, and this would just be 2x minus 5. We cannot combine those because they're not like terms. So again, step 1, first thing you always want to do with a radical equation is you want to isolate the radical. You want to get the radical all by itself. Okay, the reason we do that is because now what we can do is we could square both sides of the equation. Right? Doesn't a square cancel off with a square root? Okay, so the square and the square root are going to cancel each other off. So on the left side, we could just bring down 49 minus 10x. So we were able to get rid of that radical. And then on the right side of the equation, if something is squared, please do not try to distribute the square into the parentheses, okay? We can't do that with the exponent. It means we have 2 of these terms. So we're going to take this and we're going to write it out twice. My pen is not working. There we go. Okay. Now, when we have 2 binomials being multiplied together, we're just going to take them and double distribute. So let me first bring down the left side of the equation, and let's double distribute. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is, again, negative 10x. And negative 5 times negative 5 is positive 25. All right, so now we want to move everything to one side of the equation. Okay, we want to get one side of the equation set equal to 0. And since my leading coefficient, right, the term with the biggest exponent on it, already is a positive number, I want to keep that where it is. So what I'm going to do is I'm going to move these 2 terms. So I'm going to subtract 49 from both sides of the equation. And I like to line it up under what it's going to combine with. So I'm going to line it up under the number. And then I'm going to add 10x to both sides of the equation. Okay, and again, I'm going to line it up, I guess, underneath my x terms right here. Okay, so on the left-hand side, everything cancels. You can bring down 0 equals. And if you don't like to have 0 on this side, you can always, look at this. You can always erase that, and you can move your equal 0 right over here if you prefer. Honestly, I don't care either way. I usually just leave it over here, but that's up to you. Okay, so the 4x squared doesn't combine with anything, so I'm going to bring that down. And if I combine a negative 10x, a negative 10x, and a positive 10x, well, really what happens is, doesn't a negative and a positive cancel? So I'm going to bring down one of those negative 10x's. And then 25 minus 49 is negative 24. All right, well, what's nice is all of these numbers are even. So I'm going to divide by 2 and just make my life a little easier. I mean, you could show you're dividing by 2, but you don't have to show this. You could just do it. So if we divide both sides of the equation by 2, it leaves me with 2x squared minus 5x minus 12, and then equals 0. Okay, so I just made it smaller numbers, which usually makes it a little bit easier. All right, so now since the leading coefficient is something other than a 1, we know we're going to have to do the rainbow. So we're going to have to multiply together this first and last number, which gives us, let me do it in another color so it stands out, negative 24. Okay, there's my rainbow number. So I need to come up with 2 numbers that multiply to negative 24 and that add to negative 5. Now, before I do that, keep in mind, whenever you're doing the rainbow, we do not set up 2 sets of parentheses, okay? That's no good. What we want to do is we want to bring down the first term. We're going to leave a big space because we're going to have to put 2 terms in there. We're going to bring down this last term. Oop, this pen is giving me problems today. And bring down the equal 0. All right, so let's go back to what we were doing over here. We need to come up with 2 numbers that multiply to negative 24 and add to negative 5. So I guess that would be what? Negative 8 and positive 3. And you could do it in whatever order you want. So I'll just do it in the order I said it. Negative 8 and positive 3. And since this middle term has an x on it, we need to put an x here and here. Because remember, we're creating these two terms from this original middle term. So let's put an x on it. Okay, now we can just group. So out of the first two terms, I'm going to pull out a 2x, which leaves me with x minus 4. And out of the next two terms, since this is a plus sign, I'm going to factor out a positive, and 3, which would also leave me with x minus 4. And bring down my equal 0. Okay, so these match up, so that always makes me feel good, right? So it means we're on the right track. So let's take what's in front of the x minus 4s, and we'll group them together in one parenthesis. So we'll group together the 2x plus 3. Okay, again, you're just taking what's in front of each of these parentheses and grouping them together. And then we can bring down the x minus 4. And now we can make our t-chart and solve. All right, so if you want to physically draw the t-chart, go for it. You don't have to if you don't want to. So on this side, we know we get x equals the negative of this number divided by what's in front of the x, so negative 3 over 2. Okay, and on this side, we get x equals positive 4. It always has the opposite sign. Now, what's super important to check for with radical equations is extraneous roots. So what we want to do is we want to take a look at each of these answers. So let's start with negative 3 over 2. We want to plug that back in for x into our equation and make sure that both sides of the equation check out. Okay, so this is what I mean. So what I did was I took negative 3/2, right, and stored it as x in the calculator and hit enter. Then I typed in the left-hand side of the equation, and make sure when you do that the plus 5 is outside the radical and hit enter. It gave me 13. Then I typed in the right-hand side of the equation and hit enter, and look at this, it didn't give me 13. So what it means is this is an extraneous root. It does not check out in our equation. So I can cross that off, right? And that's called an extraneous root. Okay, so now what we have to do is we have to do the same thing for the x equals 4. We're going to store x as 4 in our calculator, and we're going to see if that checks out. Okay, so I did 4, store x, hit enter, and when I typed in the left-hand side of the equation, it gave me 8, and when I typed in the right-hand side of the equation, it gave me 8. So what that means is this 4 is a solution, so we could circle that one. All right, number 2. It wants us to determine whether this expression, oof, that's a lot going on, is equivalent to this expression right here. Okay, I'm going to start by working with this expression and see if we can get it to look like this. All right, now, we know if we have a power being raised to another power, we just multiply these. So 2 times 8 is 16, so that'll give us p to the 16th. And then 1/2 times 8, half of 8 is 4, so that'll give us n to the 4th. Okay, now this would be the square root of p to the 5th n to the 4th. So even though we don't see it, there's really a little 2 in there. I'm going to put it there. Okay, there's really a little 2 there. And the reason I'm doing that is if I want to get this, I'm going to get it out of radical form. That way I can combine it with these terms. So if I want to get it out of radical form, I could rewrite it as p to the power over root, p to the 5/2 power. Okay, I guess I'll just put this in parentheses too. You don't need it, but you can. And then this would be n to the 4/2 power. Now let's think about it. 4/2. 4 divided by 2 is just 2, so that would just be n to the 2nd power. Okay, so now whenever you're multiplying terms with the same base, you just add the exponents. So p to the 16th times p to the 5/2. Well, let's first figure out what 16 plus 5/2 is. I'm going to do that off to the side. Let me do it in a different color. So 16 over 1 plus 5/2. Okay, so if I find a common denominator, I need to multiply top and bottom of this first fraction by 2. So that would give me 32/2 plus 5/2, which would be 37/2. Okay, so I could rewrite basically this times this as p to the 37/2. Okay, and then n to the 4th times n squared. Just add the exponents. That'll give you n to the 6th. Now, that's what I have so far. Now, I could keep working with this and try to get it back into radical form, but I'm looking over here. I'm realizing it might be a little bit easier just to work with these. So let me bring down, I'm going to do this, equals with a question mark. We don't know if these are equal. I'm going to bring down the p to the 18th and the n to the 6th. And then remember, if we want to get this out of radical form, power over root. Now, even though we don't see a power, doesn't this mean p to the 1st power? And even though we don't see a root, doesn't that mean the square root? So I could rewrite this as p to the 1/2 power. All right, let me still bring down this equal sign with the question mark. Now, we might as well do the same thing over here that we did over here, right? If we want to multiply two terms with the same base, we're going to add the exponents. So let's figure out what 18, I'm going to put that over 1, plus 1/2 would be. All right, so if we find a common denominator, I have to multiply this by 2 over 2. So that would give me 36 halves plus 1/2. Look at that. That gives me 37 halves. Those are going to match. So it leaves me with p to the 37 halves. And then this n to the 6 I could just bring right down. Now, you know what? I'm actually going to erase that question mark because look at that. They are equal, right? Let me get rid of that. This over here says the same thing as this over here, so they are equivalent. Okay, and there we have it. So just write out, yes, they are equivalent. And when it says justify your answer, this work is the justification. Okay, number 3, they want to know which of the following is equivalent to that given expression. Okay, now, first thing I would do is, since these are all in radical form, I would use my rule power over root and rewrite each of these as x to some fractional power. Okay, so let's start with this. If we do x to the power over root, that would be x to the 2/3 power. I'll put that right over here, x to the 2/3 power. Okay, then times, now I know we don't see a root here, but remember, doesn't that mean the square root of x to the 5th? So there's really an invisible little 2 there. So we could rewrite this as x to the 5/2 power. All right, and then our denominator, I know there's no power that we see on that x, but we know if we don't see it, it's x to the 1st power. So we could rewrite this as x to the 1/6 power. And now from here, as long as you know your exponent rules, this is pretty, simple from this point. All right, so if we're multiplying two terms with the same base, we add the exponents. I mean, could you just plug 2/3 plus 5/2 in your calculator? Yeah, you could. I'm going to do it by hand. I'll do it off to the side here. So 2/3 plus 5/2. So we have to find a common denominator, which is going to be 6, right? So I'll multiply top and bottom of this first fraction by 2. And I'll multiply the numerator and denominator of the second fraction by 3. All right, so that leaves me with 4/6 plus 15/6. So if we add that together, that would give us 19/6. All right, so these two fractions had to give us 19/6. So we could rewrite our numerator as x to the 19/6. And that's going to be over x to the 1/6. All right, so now we know that when we're dividing two terms with the same base, we subtract these. Now, I'm not even going to do that off to the side because, look, they already have a common denominator. So isn't 19/6 minus 1/6 just 18/6? So x to the 18/6. Now, we could simplify that, right? What's 18 divided by 6? Isn't 18 divided by 6 just 3? So this simplifies to x to the 3rd power, which is choice 3. Okay, number 4. So they give us A, B, and C, and they say I is the imaginary unit, and they want to know what A minus BC is equal to. Okay, so what I did was, this is A, right? For A, I plug that in. You could put parentheses, but you don't have to. And then it says minus, and then B times C. So I plugged in B, and I plugged in C. Now, these have to go in parentheses. And to start off, some people like to distribute the negative and then make this a plus sign. Honestly, I feel like from what I see from grading, more mistakes are made that way. So what I'm going to do for right now is I'm just going to bring down this, and I'm just going to bring down the minus sign. I'm going to worry about that later, okay? I'm going to worry about that later. So what we're going to do here is I'm just going to double distribute out these parentheses. But when you do, please make sure you keep it in parentheses, okay? Because we want to subtract out this entire product. Okay, so you want to subtract out the entire product. So it needs the same parentheses. Okay, so 4 times 1 is 4. 4 times 6i would be 24i. Negative 2i times 1 would be negative 2i. And then negative 2i times positive 6i would be negative 12i squared, right? Because I times I is I squared. Now, I just want to point something out. If you recall, this is super important. I'm going to put a star next to it. I squared equals negative 1. So, technically, isn't this I squared just equal to negative 1? Like that? So since negative 12 times negative 1 gives us positive 12, okay, this right here, I'm going to just cross this off. This is going to be a plus 12 at the end of our parentheses. Okay? All right, so let me bring down the negative 3 plus 5i, and then minus, I'm still going to leave this in parentheses. I want to combine my like terms. So if we combine our like terms, we have 4, and now we have a plus 12. So 4 plus 12 is 16. And then, positive 24 minus 2i would be positive 22i. Okay, now I'm finally going to get rid of these parentheses. What I'm going to do is, after I bring down the negative 3 plus 5i, I'm going to distribute the negative. So negative times 16 is negative 16, or minus 16. And a negative times a positive 22i would be negative 22i. Okay, let's just combine our like terms. All right, so negative 3 minus 16 is negative 19. And 5i minus 22i would be negative 17i. All right, and that is in a plus bi form, right? We have an a, instead of a plus a negative is a minus, bi. All right, so that is right here, choice 3. Okay, number 5, what are the zeros? So if they want us to find the zeros, all they want us to do is set this equal to 0. Okay, so actually, this expression is already mostly factored for us. You can factor further, right? You could factor this to m plus 2 times m minus 2. And unfortunately, this one can't factor further because of the plus sign. If that was a minus sign, it would be a difference of perfect squares. But I'm going to show you, even if you don't factor further, if you just jump right into a t-chart, you will still wind up with the correct answers. Because think about it. If you took each of these factors and set them equal to 0 and solved, you will wind up with the correct solutions. All right, so let's think about it. If we were to solve this side of the equation, right, not using our factoring method, like I know this could factor to m plus 2 times m minus 2, but another method, can't we just add 4 to both sides of the equation, leaving us with m squared equals 4, okay? And then to get rid of a square, we could just take the square root. Now, this is super important. Please do not write m equals 2, okay? Because see this square right here? Doesn't that tell us that we could have up to 2 answers? And in this case, we do. We have positive 2 and negative 2. Think about it. If you had taken a negative 2 and substituted it in for m, isn't negative 2 squared negative 2 times negative 2? Positive 4. Wouldn't that also be a solution? Okay, so these are 2 of our solutions. And then let's do the same thing over here. Let's subtract 1 from both sides, leaving us with m squared equals negative 1. And let's take the square root. So again, that leaves us with m equals, don't forget that plus and minus. And do you remember what this is equal to? The square root of -1? That's equal to I. Okay, so we wound up with a total of 4 answers, positive and -2, as well as positive and negative I. So that is choice 4. Okay, so number 6, they want us to find the solution, express it in a plus bi form, and then determine what the value of b is. Okay, so first of all, if we were to solve this equation, all right, let's first distribute the 2 into the parentheses. So that'll give us, let me do it down here, 4x minus 2 equals 5x squared. Now we want to get everything to one side of the equation. Personally, I would not take this 5x squared and move it over, because then we're going to make it negative. Like, why do that, right? Why have a negative leading coefficient if you don't have to? So instead, I'm going to take these 2 terms and move them to the right. If you prefer to write out all the work, right, minus 4x and minus 4x, and write plus 2 and plus 2, okay, you can. That would leave you with 0 equals 5x squared minus 4x plus 2. But honestly, I don't care if you show that work, because I'm okay with you realizing if you take a positive 4x and move it to the other side of the equation, it becomes negative. If you take a -2 and move it to the other side of the equation, it becomes positive. So this step is unnecessary unless you individually like to show it. Okay, now this is letting me know I'm probably going to be using the quadratic formula. With the quadratic formula, so many of you forget to write x equals. Please do not forget to write x equals in front of that. That's a point off. See how this is an equation? Okay, you need to keep it an equation the entire way through. All right, so when we use the quadratic formula, let me just write out over to the side here. A, B, and C. And by the way, this B is not what they're looking for here. Okay, they're saying once you solve and write it in this form, what is basically the value in front of the I. Okay, but my A is 5, my B is -4, and my C is 2 within the quadratic formula itself. All right, so I'm going to plug these in the quadratic formula. So x equals -b, so -4 would be +4 plus and minus the square root of b squared. So you could either put in -4 in parentheses and squared, or you could just write 16 minus 4 times A, which is 5, times C, which is 2. And that whole thing is going to be over 2 times A, so 2 times 5. All right, so we have x equals 4 plus and minus the square root of, all right, so let's see, this is 16 minus 40 would be -24. And that whole thing is going to be over 10. Okay, don't forget to extend the fraction bar underneath the whole thing. All right, now the radical -24, I'm going to simplify that off to the side. So I know a positive 24 breaks up into radical 4, radical 6, but I also need to make a third radical because of that negative. Okay, so the square root of 4 is 2. The square root of -1 is I, and I'm going to bring down that radical 6. All right, so what we want to do is, in place of this radical -24, we're going to substitute it with 2i radical 6. So that leaves us with x equals 4 plus and minus 2i radical 6 over 10. All right, so let's look at all these numbers here. So we have a 4, a 2, and a 10. So you could do one of two things. You could either first break it up into a plus bi form and then simplify, or you could simplify and then break it into a plus bi form. It doesn't matter either way. All right, so if we want to see what's the biggest number that divides evenly into all of these, it would be 2, right? So the 4 would become a 2. Again, don't forget x equals, right? The 4 would become a 2. The 2 would just become a 1, so 1i, or you could write I radical 6. If you want to put the 1 in front of it, you can. And then 10 divided by 2 would be 5. Okay, so all we did was we just took each of these 3 numbers on the outside of the radical and divided them by 2. So now if we want to break this up into a plus bi form, the a would be 2 over 5. Okay, then we have our plus and minus. Now you could do this one of two ways. You can either just leave it as I radical 6 over 5, Or what some people like to do, let me see if I can squish this, is they like to pull the I on the outside and write it as 2/5 plus and minus. They like to take this I and bring it to the outside. So you'd have radical 6 over 5 with an I right there. Okay, now if we go back to the question, I've got to scroll up a little. They wanted to know, once we write it in simple as A plus BI form, what is the value of B? So the B is what's in front of our I. So look, here's the I. So this right here would be the B. So radical 6 over 5. All right, so that is choice 2. Please don't pick choice 1. They don't want the I included. They want just the B, what's in front of the I. So radical 6 over 5. Okay, and then finally, I think this is the last one in this section. Number 7, a 4th degree polynomial has these 4 zeros. Okay, which graph could represent the function? All right, so it looks like here we have 2 real zeros. So the real zeros are where the graph is going to intersect the x-axis. So it has to intersect the axis at -5 and +3. So right here, -5 and +3. -5 and +3. It cannot be these. Zeros are where the graph crosses the x-axis. Look at this. Here they reverse the signs. You only reverse the signs for factors. Zeros are where the graph crosses the x-axis, so it's not going to be these. Okay, now, if the other 2 zeros are imaginary, they are not going to cross the x-axis anywhere other than at the real roots. So since there are 2 real roots, there are only 2 x-intercepts. Choice 1 has 1, 2, 3, 4. Choice 2 only has 2. So choice 2 would be the answer. Okay? Again, I want to point out the number of real roots is equal to the number of x-intercepts. Let's write that out on our paper. Okay, so let me actually just move this down. There we go. So the number of real roots, since we had 2 real roots, will equal the number of x-intercepts. So we have 2 x-intercepts. Okay, so choice 2 is our answer.